All right, today we're starting our unit over statistics. So we'll be dealing with data that has two variables going on since we've just been working on linear equations, which also deals with two variables. So this week we'll focus on scatter plots, which is what we're going to introduce today. And next week we'll do what we call two-way tables, but both are called bivariate data because they have two variables. So the first one we'll focus on is a scatter plot. This says, and this is already printed for you in your guided notes, but let's go through what it says and what it means. A scatter plot is a graph that shows the relationship between two data sets. So a lot of other statistics you've seen in the past, like bar graphs, pie charts, are collecting one piece of data. Scatter plots and two-way tables are collecting two pieces of data so we can compare how they're related. The two sets of data are graphed as ordered pairs, so we'll be plotting points, just like we were in our last unit, in a coordinate plane. All right, and we'll also be using lines of good fit, lines of best fit in this unit. So we'll be using a lot of our knowledge from our previous unit. Okay, steps to make a scatter plot are to label your axes because we want to know what we're talking about. So we'll label what X means, we'll label what Y means, and usually we also title our graph as well. So I'll show you what that means when we make an example. Step 2 is to make a scale. A lot of times we're going to provide you one, but we also want you to be able to kind of reason through how to make one. So we know that can be challenging and it's something we want to work up to, but we will scaffold and put those scales in for you while we're just starting out. But just know making a scale is part of our steps as well. And then the last step is to actually plot our ordered pairs. So we're going to take these steps, keep them in mind, and apply them to a couple of examples. So step 1 is to label. This is make a scatter plot of the data, identifying any outliers, gaps, or clusters. So we're also going to talk about what those three things are. So it looks like we are dealing with age. Remember, in a t-table, age, or whatever's on your left, is your x variable, and this is your x-axis. So we have age down here. And then our y-axis, in this case, is data used in gigabytes. So age and then data used. See if I can write sideways here. And those, like I said, are already labeled for you on your graph, but we do think it's important that you start to recognize how they got there. All right, so next let's talk about our scale. So our scale in your notes is already counting by tens, but I want to talk a little bit about how we got there. So when we are trying to make our own scale, or what we should count by, because if we count by ones, our data is not going to fit on there. But if I look here, it looks like my smallest age or youngest person is 25. And then it looks like my oldest person here is 65. So I need to make sure that I can fit all the way up to 65 on my graph. Okay, so sometimes you'll see a break like this, and then people might start at 20 instead of starting at 0. I'm not going to do a break since 25 is still pretty close to our start, and we're just going to count by tens. And again, this is labeled for you, but I want to talk about how we got there because it won't always be labeled for you. So let's say each one of these is 10, and that gives us a nice even spacing. Like, we don't want everything to be tiny in the corner, and we want everything to fit. So I have a little bit of extra space, but not a lot. And then if we look at our Y's, it looks like my smallest value is 9/10 of a gigabyte, and my largest one is 3.5. Okay, so we need to get, like you can see on your graph, we need 4 maximum, and we kind of want to spread them out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can kind of skip and put 1 here, and then 2, 3, and 4. Okay, and that just makes everything nice and even. We're kind of zooming in on our picture, if you will. We don't want everything to be tiny in the corner. We want to be able to see it nice and big while everything still fits. Okay, so that is our second step. First, we labeled, so age and data used. Second, we made our scale, which is we counted by tens on the bottom. We skipped counting by ones along the y-axis. And our last step is to plot our points. And I highly suggest you do this, to cross them off as I go. There are so many points that it's really easy to lose track. We need to cross them off as we go. So this person is 37 and used 3.2 gigabytes. So 37 would be in between 30 and 40, closer to 40. And then 3.2 would be a little bit above 3. So you are doing a little bit of estimating where these points go, but you want to try to be as accurate as possible. So I'm done with this one. Okay, I'm just going to check it off so I can still see what it was, but that I know that I've done that one already. 30 would be right on the 30 grid line, and then 3.3 would be right around here, just below that 3.5. 32 would be just a little to the right of 30, and then just above 3 for that 3.1. 65 and almost a full gigabyte, so right between 60 and 70 and just below 1 here. Then we have 53 and 1.8, so just to the right of 50, just below 2. 25, 3.5, so right between 20 and 30. 3.5 is also right here, right in between 3 and 4. 59 and 1.3, so just before 60, just below 1.5. 30 and 1.8, so on the 30 grid line, just below 2. 50 and 1.9, so on the 50 grid line, just below 2. And 34 and 3.3 would be in here. Okay, now let's talk about outliers. Outliers are pieces of data that don't fit. They're kind of all off on their own. Okay, they don't fit. So I would say an outlier will be this point way off by itself right here. Gap is a break between data points. So there is a gap right here in between these two. Okay, this space is a gap. And then clusters are groups of points. So groups. So I would say our clusters, we have 2 of them. Those would both be a cluster. Okay? So that's really what we're doing today. We're trying to make the picture and then identify those 3 things: outliers, gaps, and clusters. All right, we're going to do one more example to finish out our notes today. So we have a new situation here. We have study time for X and test score for Y. So my first step is to label those axes. And again, they're labeled for you today, but we want you to get in the habit of doing that, or at least knowing where they come from. So we have study time for X and test score for Y. So I've labeled my graph so we know what we're talking about. And then I have to figure out my scale. So it looks like I need my study time to range from 10 to 120. So we need all of it to fit. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces, I need to at least count by 12s to get everything to fit here. But it looks like on your graph, we went ahead and counted by 10s. So that last one, we're just going to add a couple tick marks, I think. So here we have 10, 20, 30, and so on. Because it is easier to count by 10s than by 12s. I think that's why we did that. So then you have 100. I'm going to extend this just a hair for 110 and 120, because we do want everything to fit. Okay, our test score, it looks like it ranges from 62 to 97. So we want our test score at the very smallest to be 60 all the way up to, let's just round up to 100. So it looks like we're counting by 10s again, which is very common for test scores. If we have 10 lines and the highest score you can get is 100, it would make sense to count by 10s. 80, 90, 100. Okay, so that's step 2. We've labeled our axes. We did go a little bit off here, but that was just because it's a lot harder to count by 12s. So now we're going to plot our points. That's step 3. So 30, 80, that should be right on the grid lines. 30 up to 80 would be right here. And check them off as you go, but make sure you can still read them. 20 to 74, so right on the 20, in between 70 and 80. 80, 95, so right on the 80 up to 95. 90, 97, right on the 90, just below 100. Okay, 45, they studied 45 minutes, they got an 85%, so right between 40 and 50, and then right between 80 and 90. 10 minutes, 62% would be here. Studying for 30 minutes, got an 83. 75 minutes, got a 90. 120 minutes, got a 70. Floating over there. And then studied for 80 minutes, got a 91. Right here. Okay, and then let's talk about our outliers, gaps, and clusters again. So an outlier, in this case, I would say is this one. Okay, not only is it off our graph, but it's also well below the other points. And it would be unusual to study for 2 full hours and then still only earn a C. So that was an outlier, okay, right here. So we can also put that as the ordered pair, 120, 70%. Our gap, I would say, is right in here between these two groups of points that we would call clusters. And actually, this one's a little bit spread out, but because they kind of share the same pattern, they're both kind of trending upwards, I think I would still call that a cluster. So there is a little bit of opinion in this. It's not a perfect exact science, but for the most part, it's a group of points, it's a cluster. All right, that's it for our notes today. We are working on a worksheet next.